You are welcome back. In this video we are looking at exponential equations and indicial equations. Okay, so that's what we are looking out for. So if you are new here, consider by liking, sharing and subscribing. Most important, subscribing to this channel. But I've given the link, the 3 lessons link in the description section of this video. You can check and watch the previous lesson that we have done so far on indices. All right, so we are looking at exponential equations or indicial equations. We are saying that exponential equations are equations which have the variable or unknown quantity as an index or exponent. So for this is what we are saying, that if I have a raised to the power x, and let's say this is also equal to a raised to the power y, the unknown variables or quantities here are what? The x and what? Y. That's what we are saying now, what? Exponential indicial equation. And we are saying that to solve such equations, we always use the fact that a raised to the power x is equal to a raised to the power y, since they have equal base. Therefore, we can say that x is equal to y. You can make that implication that x is equal to y. But the condition here is that provided a is not equal to 0, either 1 or -1, or better still -1, 0 and what? And 1. Provided a is none of these numbers here or integers here, we can solve for the unknown what? Variables or quantities. So that's why we're saying the exponential equations are equations which have the variable or unknown quantity as an index or the exponent. So provided a is not equal to 0, 1 or -1, 0 or what? 1. So that is what we need to know. So let's take an example. Example 1. If 3 raised to the power x is equal to, if 3 raised to the power x is equal to 81, find the value of x. So here, to find the value of x, straight away we are going to apply our rule here. We need to have what? Equal base. So here, since they are not equal, I can't apply. So therefore I can say that to have equal base, how many, which number should I raise? Because here is already 3, so mean that is the lowest base. So mean that I can get 3 from the 81 and I can raise to a particular number. Now at the end they're going to give me what? 81. So here it becomes 3 raised to the power x. So all I will need to do here is to take 3 and raise to the power a number which is going to give me what? 81. And what is that number? 3 times 3 is going to give me what? 9 times 3 is 27 times 3 81. So mean that 3 raised to the power 4 will get me 81. I hope it is clear. Great. So now once the bases are equal, therefore we can say that x is equal to what? 4. So that is my answer for x. Alright, so that is how they are. So here, always make sure that the left and right have equal bases, then you are good to go. You can now therefore compare the exponent. Okay, let's take example 2. Example 2. The same preamble. If I have 3 raised to the power x plus 1 and it's equal to 9 raised to the power 4, then I'm asked to solve for find x, find the value of x. So I'm asked to find the value of x. So all I'll be doing here is straight away by ensuring that each base is having what? The least base that I can easily equate my exponent. So here it becomes 3 raised to the power x plus 1 is equal to 9 raised to the power 4. So mean that since I'm having the least base to be 3, therefore I can say that here 3 raised to the power x plus 1 is equal to, so how many, which number should I choose? What, 3, right? So 3 raised to the power 2 gonna give me 9, isn't it? But remember, it also raised to the power 4, so it gives the overall what? Exponent. So here, this is what we're doing. 8 multiplied by 4 gonna give me what? 8. Sorry, 2 multiplied by 4 gonna give me what? 8. So here it becomes 3 raised to the power x plus 1 is equal to 3 raised to the power what? 8. I hope that is clear. So once you're able to get that, therefore, since the bases are equal, therefore we can say that x plus 1 is equal to 8 per our exponential or indicial rule. So therefore I can say that x is equal to 8 minus what? 1. Okay, I hope everything is clear. Therefore I can conclude that x is equal to what? 7. Then I'm good to go. So here, because the bases are what, be able to make the base to what? Equal. That's why we're able to equal the exponent. So that is for example 2. So let's take the next example. Example 3. Example 3. Alright, these are our last set of questions and exponential indicial, and it's example 3. We are asked to solve for x in the following, that's a and b, but c has its own requirement. So let's move on to a. So a, we are having 3 raised to the power x raised to the power 2. 3 raised to the power x minus 2 is equal to what? 1 over 81. Okay, so here, this is what you need to do. All that you need to do here is to have an equal base as always. So I'm going to get 3 raised to the power x minus 2. Then I'm going to take, how many times can we raise what? 3 to get 81, which is 3 raised to the power 4. But here, remember, it should be 1 over 3 raised to the power 4 before I can apply my other properties I've learned so far, which is 3 raised to the power x minus 2. So therefore, if I want to have it in horizontal, it becomes what? 3 raised to the power negative 4. I hope that is clear. 3 raised to the power negative 4. Alright? So here, once they are equal, therefore I can say that, can imply that x minus 2 is equal to negative 4. So therefore I can say x equal to negative 4 plus what? 2. Because x equals, therefore I can say x equal to 2. Sorry, negative 2. Remember, here is negative 4. So when I add 2, it becomes what? Negative 2 for you. Then b. I hope everybody is okay. I hope everything is going well. Alright. So let's take on to the next b part. The b part is saying that if I have 3 raised to the power 2x minus 4 on to bracket 3 raised to the power x. If you don't understand anything, please let me know by commenting so I can get it. It's equal to 0. Therefore, I'm asked for my x. But here, there's a different condition altogether per what we have started solving. Now, we are saying what these are items, these variables in here. So how do you go by it? So here, all I need to do is ensure that you use this as your base, 3 raised to the power x. So you change everything to ensure that you get to, at the end of the day, you get what? 3 over 3 raised to the power x as the base you want to use as a measure. So I can say that here, I can have here to be 3 raised to the power x, okay, or raised to the power 2. I can do that. At the end of the day, it is 2 multiplied by x, the exponential law of multiplication. Just multiply the exponent and you're good to go. Then I can also say that 4, this one remains in its original state. Likewise, this and it's equal to 0. Okay, so now once I'm able to get that, therefore I can conclude by saying that now, if that is the case, therefore I can say that let 3 raised to the power x be equal to, say, a. Okay, so if that is the case, therefore I can say that any where in this equation that I see 3s, I'm starting with what? A. So here becomes what? A raised to the power 2 minus 4a, right, plus what? 3 is equal to 0. So with the help of my calculator, I can solve for the values for a. So with the help of my calculator, I can solve for my a. So with that, I'll get a minus 1, then a minus 3, all equal to 0. So I can say that therefore a is equal to 1 or 3. So but we said that let's what 3 is equal to a. So since that is so, therefore we can say that if I have 3x and is equal to 1, I can safely say that here I'm going to get 3 raised to the power x, and here is also 3 raised to the power 0. If you remember, a number raised to the power 0 is what? Is one non-zero number, right? So therefore I can say x equal to 0 as my first what? X. Then when it comes to the 3, it's also 3 raised to the power x is equal to what? 3. So here it's having an exponent of what? 1. So now they have equal base. So therefore I can say that that one too can imply that x is also equal to what? 1. So roughly we can say that x is equal to 0, 1 for the B part. So let's take note of that as your final answer. So if you have any question of this nature, always make sure that you get what? A standard or a standard base where you can actually make sure that all the terms get the same stand, so that you can actually make that one as you can replace any letter with that variable, that quantity, then you can solve for one so that you can come and do substitution at the other, as we have done here. Here you just make the 3 raised to the power s as the standing point, so that we can use to measure or change others to have the same reflection or image as that of this 3 raised to the power s. And that's why we go through, then we say let 3 raised to the power s equal to a, then we're able to do that, and we're able to arrive at this space, then we're able to solve. So that's how, when you get this kind of question, exponential, this is how it should be done. So let's take note of that. Then let's take the last aspect under this. So this the last question on example 3. We asked for x and y. Remember, here is my equation 1. Okay, but here, because of the 1/4, which is a fraction, we need to change everything so that we can actually have a mirror image like the equation 1. Okay, so here I can say that here can have 2 raised to the power x plus y, and should be equal to 1/2 raised to the power 2, isn't it? 2 raised to the power 2 is what? 4. Okay, so therefore I can say that 2 raised to the power x plus y will be equal to, with my third property of 2, we can say that here is 2 raised to the power negative 2, isn't it? So once they have equal base, therefore I can say that s plus y is equal to negative 2. Okay, so I can say here is equation what? 2. So if that is the case, therefore I can use my elimination method to solve for x. I can say that let x from equation 2 be equal to negative 2 negative y. Okay, so I'll substitute x, which is equal to negative 2 negative y, into equation 1. Okay, so once I do that, then any variable s in equation 1 that is here, I'm substituting for negative 2 negative y. So here it becomes negative 2 negative y plus 6y is equal to 3. So here now I have the values being established here. So negative y plus 6 is gonna give me what? 5y. Okay, then I'm having 3 here. Here is negative 2. Once you join the 3 becomes what? Positive 2. Alright, so therefore I can say that 5y is equal to 5. So divide both sides by 5. I can say that y is equal to what? 1. So if y is equal to 1, then we can say that from equation 2, we can say that therefore x is also equal to -2 and y was what? 1, so -1. So therefore x is equal to -3. So you can finally say that x is equal to -3, y is equal to what? 1. If you don't mind putting them curly bracket, especially the two set, you'll be good to go. So that is the approach that we actually talk about. So if you have any exponential question of this nature, this is how it goes. All I need to do is change the exponential equations into let's say a linear equations, right? Or any equations of that kind, so that you can actually deal with the other equation where it's not an exponent. Okay, then you solve for your values in that question. So this is how you solve this kind of questions in there, and you solve them with a simultaneous approach. So here I use elimination method. I make one of them the subject, and then I substitute. Sorry, I said I use elimination. I use substitution method. The method I use was substitution method by making one of them the subject, then substitute into the other. So this is how these kind of questions are solved. So let's take note of that. So this is where we bring an end to our discussion or lesson on what indices. This is where we bring an end to all. So in the next video we're going to do, we're going to take into account logarithm and other aspects of logarithm. So thank you once again for watching this video. It's been a pleasure coming your way to assist you and helping you to pass your examination. Thank you once again. See you. Bye bye.